Okay, so we have looked at surface maps. Now we're going to go to where the real work of the atmosphere happens, and that's in the upper levels. But that term upper levels is a bit deceiving because we're only going to get a very short way up the atmosphere. Let's review a bit. You know this graph real well. It is talking about air pressure on the x-axis and it's talking about altitude on the y-axis. And you know that 90% of the Earth's atmosphere is within the first 10 kilometers of the entire atmosphere. The atmosphere goes on perpetually. It has no lid, it has no cap. But 90% of the atmosphere is within the first 10 kilometers, very, very low on this chart. And look what we're doing for the upper levels. We're staying within the first 10 kilometers. We're looking at sea level at a surface level, and then we will look at charts like 750 millibars, 500 millibars, 300 millibars. Let's go into the altitude of each of those upper level charts. I think you'll be surprised. The upper level maps at, let's go really high, 30,000 feet, right? 30,000 feet, about 9 kilometers. You're right underneath that 10-kilometer limit, and you're within 85 to 90% of the total atmosphere. We're going to concentrate on a type of upper level map that is at 500 millibars, or about 5 kilometers high, or about the height of a high peak in Colorado. All right? And we also may talk about the 300 millibar level that's about 9 kilometers high. That is basically where the jet stream are and where jets do fly to try to meet the jet stream. So we'll talk about that as well. We're going to start with the lower levels. We're going to start about 3 kilometers high, about 10,000 feet, at about the 750 millibar level. And we may even start even lower than that, at about 850 millibars. But you should know that these are all off the surface. They're known as upper level maps, but they are not very, very high in comparison to the entire atmosphere. In fact, the tropopause is right around 13,000 meters. That's up about 45,000 feet, 50,000 feet. That's at the 200 millibar level upper map. We won't really go into that very much. The steering level is that 500 millibar map. That's up around 15,000, maybe 18,000 feet. High mountains up there. So let's look into what we're doing by using a lower map first. Then we'll get into the higher maps. We are going to look at an 850 millibar map. And what this is it is comparing the sea level right here and the sea level as a surface. Remember, we corrected all of the altitudes of mountains down to sea level so we could compare them all on one horizontal plane, look for horizontal differences. We're going to look for the horizontal differences throughout the atmosphere as well. We're going to create a horizontal plane out of one pressure, out of the 850 millibar pressure. Now, what does that mean? Well, if I have 1,000 millibars above me at sea level, it means that at this horizontal plane, I have 850 millibars of pressure above me. This is generally, it can go anywhere from about 1,200 meters high to about 1,800 meters high. What's the difference? The difference is in the temperature of the air and the density of the air. I think you can imagine that this cold air here on the downward part of this horizontal plane is where approximately 150 millibars of cold, dense air is. I say 150 millibars because 850 millibars above plus 150 millibars equals the 1,000 millibars at sea level. Let's go to Florida, where you have a lot of warm air with a lot of energy. That same 150 millibars of pressure that is between surface level and 850 millibars can take up a lot more volume. So that can actually take up a lot more altitude of 1,800 meters. When we look at these maps, and you've now seen the cold air over here and the warmer air, and you've seen Florida air at about 1,800, you realize that this is a continuum. This horizontal plane actually has some curves to it to go up and down. So it doesn't have to stay flat. It can have a warm sector over Mexico, a cooler sector over the Gulf of Mexico, a warm sector again over Florida. It's a curved plane, and those curves really depend on the temperature of the surface air, and that often depends on the latitudes that we're dealing with or the topographical characteristics. For instance, Mexico, Gulf of Mexico, and Florida. So in addition to that, you should know that those curves, again, they're acting like a person is standing on the plane here at 850 millibars, and the person has 850 millibars of pressure above them. This is kind of like a topographical map for air in the upper atmosphere. And we're going to move from that 3D map to a 2D map that's more like a topographical map, and that's here. And that may look like what you might know for hiking. And it shows the altitudes of the air. For instance, 1,500 meters for the moderately warm air, 1,800 meters for the really warm air out of Mexico and Florida, and 1,200 meters over the cooler Gulf of Mexico. Because remember, water has a higher specific heat. It takes longer to cool. So this is the topographical map that we're getting into. To overlay topographical areas like the United States under this map, so you can see now, you can see Baja California, you can see Mexico, and you can see Florida in here as we overlay the topographical map onto the physical map of the United States or of the world. And in addition to that, we can note that you are predicting on this physical map that there will be lower altitudes for 850 millibars of pressure when you're north. And that makes sense because there is more dense and colder air up north. So it makes sense that that air would not rise so much. You'll have a lower altitude. Conversely, you'll have a higher altitude when you go south at about 1,800 meters of altitude there. On these maps, you can also put wind direction as well. So we're trying to complicate them a little bit more and add some more information. When you look at these maps, you'll notice that these curves form troughs, and they can form ridges. The troughs are usually associated with cooler air that is lower in altitude. The ridges are associated with warmer air that is really lifting those altitude levels for the 850 millibars of pressure. So we talk about troughs for cold, dense air, and we talk about ridges pushing up the altitude of that 850 millibars. Let's go to a 500 millibar map now. They look the same, it's just that the altitudes are different. We were noting on the 850 millibar map altitudes around 1,500 meters. Now on the 500 millibar map, we're higher up in the atmosphere, altitudes around 5,000 meters. But you see the look is still the same. And this 500 millibar map is a surface that shows altitudes where there are 500 millibars of pressure above the altitude and above the horizontal plane there. Let's go to the rest of it after this.